Today we're going to be going through chapter 4, number 39. And this one has a rifle. It shoots a bullet at 460 meters per second. It's aimed at a target 45.7 meters away. If the center of the target is level with the rifle, as we've drawn, how high above the target must the rifle barrel be pointed so that the bullet hits dead center once it has the effect of gravity and it comes back down? So I've started by drawing this image. So it, in my opinion, it's always easier to see what we're doing instead of just imagine it from the words. So I've drawn a projectile, the distance here, 45.7, and I just started writing down everything that I know, because I know that my initial velocity is 460. I know Vx the whole time, because my Vx is going to be constant, is V naught cosine theta. My initial Vy is V naught sine theta. And then my final Vy, since projectile motion is symmetric, is negative V naught sine theta. And so from here, I also wrote down our kinematic equations, because we know that we can use these either completely in the x direction or completely in the y direction. And so with a problem like this, in my opinion, is not altogether obvious how to begin. And so I just look at what we have and I look at what we can work with, kind of like our toolbox here. And then I just start with something that seems to make sense to me. And if you start with something that makes sense and then it doesn't work, you can go back and try something else, and that's no problem. So what I'm going to start with is our first equation, V final equals V initial plus AT. And really what I want to get is I want to get this theta right there. Because if I have theta, I know that the whole distance is 45.7. And if I have theta, then I can figure out how far above are we aiming just using tangent. And so if I can find theta, then we're almost there. So I will use my y velocity, initial and final, with this equation. And the reason why I wouldn't use x is because x will be the same at the beginning and the end, and the acceleration is 0, so that wouldn't tell me anything. So my final, I'll have negative V naught sine theta equals V naught initial, which is V naught sine theta, plus gravity is our acceleration, negative 9.8, times our time. And so I will move this over here and have negative 2 V naught sine theta equals negative 9.8 t. And then if I cancel out my negatives and solve for my time, I will find that I have 2 V naught sine theta over 9.8. So obviously I'm not done here, but I have an expression with theta in it with time. And so now I'll go back to my toolbox and try to figure out something else that I might be able to use. And so I'll look at the second equation, and I know that I'm going to have to use 45.7 some way to solve this. And so I'm going to try to use this in the x direction with the second equation. So let's put a little box around this so we know we're done with that for a minute. So x final is going to be 45.7. My x initial starting here is 0, plus my initial, and of course now we're dealing in the x direction. So my initial x velocity is V naught cosine theta times time. But luckily for us, time is always the same between the x and the y. And so I'm going to plug in what we have right here for my time. So I have 2 V naught sine theta over 9.8, and then plus 1/2. Very fortunately for us, the acceleration in the x direction is 0. And that's super fortunate because I wouldn't want to have to square that. So this becomes 0. And now we have an expression with everything we know. And the only thing we don't know is theta, which is great news because that's what we want to figure out. And so I'll simplify this a bit. So we have 45.7. I'm going to move my 9.8 over here times 9.8. And let's see, I have a V naught right there and a V naught right there. So that's going to be V naught squared, but I'm going to move it over to the bottom here. So V naught squared. And we know that V naught, by the way, is 460. So that is a known quantity. So this will equal 2 sine theta cos theta. And since we took math classes, we remember that 2 sine theta cos theta actually equals sine 2 theta, which will make this problem a lot easier for us to solve. So I will have 45.7 times 9.8 over 460 squared equals sine 2 theta. If I work this out, this whole quantity ends up being about 0.0021164. So this equals sine 2 theta. So I'll take the arc sine of both of these, and then that will give me 0.1212689 equals 2 theta. So if I divide that by 2, I finally found my theta, which is a very small theta, but that's okay. Sorry, 0.60634. I'll write that again for you since that is almost illegible. So this is our theta. And so that's really, we're almost there, because now I know that that is this angle right there. And so tangent of that theta equals y over 45.7. And we know that theta, so we'll use my calculator to solve for the y. And the y equals 0.0484. And of course, that'll be meters. And so to answer the question, how high above the target must the rifle barrel be pointed? It must be pointed 4.84 centimeters above the target. Bum, bum, bum. And we're done.